Okay, so today what I want to do is do a lesson on simplifying radicals. Now, this is a lesson that I know that you're going to need throughout the rest of your high school career. That's why we're doing that. This is not busy work. This is something you're actually going to need for geometry and algebra 2 and college algebra. Okay, I've taught geometry, I've taught algebra 2. I know you're going to see these things again, and I want to make sure that you have had access to learning that. So that's what we're doing this today. So, like I said, it kind of looks like we've kind of been jumping around on lessons lately, but that's just because I want to expose you to the most important things that I know you're going to need for geometry and algebra 2. And this one is a major one that you're going to need for geometry and algebra 2 both. So, simplifying radicals. Well, you might be thinking, what is a radical? And if you can tell by these problems here, a radical is just a square root. Okay. Sometimes you have cube roots and sometimes you have fourth roots. But a radical is just basically a square root or a cube root. These are all going to be square roots. So if you don't see a little number in the little corner, it's always an understood square root. So that's what we're going to be doing. Now, this is not going to be taking square roots in our calculator. So we might use our calculator to help us find numbers that go into these numbers, but we are not going to punch it in and get a decimal. Okay, so I don't care that the square root of 12 says 3 point something in your calculator. Okay, if you give me decimal answers on your worksheet on this, I'm not going to give you credit for it. Okay, this simplifying radicals and putting them in there and approximating square roots using decimals are two different things. Okay, so I'm going to teach you how to simplify radicals. All right, so to simplify radicals or to take a square root, we first need to understand squares. Okay, so here's a list of squares. I miss you guys helping me make my squares list, but it's helpful to have you a list of squares. So it might be helpful for you to take a piece of paper out while we're doing this before you do your worksheet and copy these with me. So 1 squared is 1. So I'm writing my squares in red. Okay, so it might be good to go back and highlight those numbers or something. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. 20 squared is 400. 20, and I'm skipping a few because these are just going to be the most common ones you'll see. 25 squared is 625, and 30 squared is 900. So I skipped some at the end just because I don't think you're going to see anything else in the 20s except for 25 squared maybe, and 300 and 30 squared is 900. So that's my separate piece of paper. Okay, so I've got that saved in my other little location on here so that I can refer back to it. But all the numbers that I have in red are my what we call perfect squares. Okay, so all these numbers that are red are perfect squares. So when I'm talking about what is a perfect square or what number is a square number that goes into these numbers, the red numbers are what I'm talking about. Okay, these are my perfect squares. So let's see some examples. First of all, the first one, radical 64, that just means what's the square root of 64? Well, 64 is a perfect square, and the square root of 64 is 8. Okay, so the square root, taking a square root or radical of something is the opposite of squaring. So remember, squaring a number and taking a square root are mathematical inverses of each other. So they undo each other mathematically. They cancel out the operation. So when you square a number, it's the opposite of taking the square root and vice versa. So the square root of 64 is 8 because 8 squared equals 64. Okay, then we get down here to 12. 12 is not a perfect square. There's nothing that multiplies times itself to get 12. Okay, so what we have to do is we have to simplify this radical. Now, the way we simplify a radical, like I said, I'm not impressed. Do not type that in your calculator and get 3 point something, even though that's what your calculator says. Okay, that's not what we're doing here. So to simplify the square root of 12, what we need to do is we need to know the largest perfect square that goes into 12. So I'm going to go over here to my list of my perfect squares. Well, 12 falls, let me use blue so I can know what to erase. 12 falls between 16 and 9, right? So my numbers that could possibly go into 12 would be the numbers from 9 down. And there's only 3 of those, 9, 4, and 1. Well, 1's not ever going to get you anywhere, okay? So does 9 go into 12? No. Does 4 go into 12? Yes. So I'm going to need my 4. Okay, so I go back to my problem. Square root of 12, I'm going to change that to radical 4 times, well, what times 4 equals 12? 3. Okay, so you want to know the perfect square number that goes into 12, and you really want the largest number that goes into 12 that's a perfect square. So square root of 12 is the same thing as the square root of 4 times 3. Well, I can take the square root of 4. The square root of 4 is 2. So you bring that square root to the outside. So the square root of 4 is 2. So you bring 2 to the outside, and you can't do anything with a 3. So 2 radical 3 is your simplified answer. So whatever your second number is there that you cannot simplify, you leave that under the radical. So 2 radical 3 is how we simplified radical 12. Okay. So let me go back to my picture here and erase. All right, so example 3 here, I want to find the square root of 90. Again, we're not putting that in the calculator and getting 9 point whatever. That's not right, okay? We're going to simplify radical 90. So I need the largest perfect square that goes into 90 that I can break up 90 into, the factors of. So back here to my notes, 90 is going to fall between 81 and 100. So anything from 81 down to 1, and 1 doesn't help us, are the square numbers I need to check. Okay, so the key to finding the largest is using your chart. Does 81 go into 90? No. Does 64 go into 90? No. Does 49? No. Does 36? No. Does 25? No. Does 16? No. Does 9? Yes, 9 goes into 90. So you change radical 90 into radical 9 times 10, because 9 times 10 equals 90. And the square root of 9 is 3. So that simplifies to 3 radical 10. So you pull the square root to the outside. And there's no perfect squares that go into 10, so that is my simplified answer. Okay, so you just kind of use your chart. You're only working about those red numbers that I have in the chart, the perfect squares, to see if they go into. Now, 72 is a fun number just because there's quite a few perfect squares that go into 72. 4 goes into 72. 16 goes into 72, I believe. No, I'm wrong. It does not. 9 goes into 72, but that's not the largest one. The largest perfect square that goes into 72, if you use your chart, is actually 36. So 36 times 2 is 72. So you take the square root of 36, which is 6, and you pull it to the outside. So this simplifies to 6 radical 2. Well, you might be thinking, and this is a good time to do this, what if you accidentally didn't think of 36 and let's say you use 9 times 8. Okay, so say that you couldn't think of 36, but you did think that 9 is a perfect square that goes into 72, and it is. And you use 9 times 8. Well, 9 times 8 is 72. Well, the square root of 9 is 3, so you pull that out and you get 3 radical 8. But wait a minute, 8 has 4 that goes into it, and 4 is a perfect square. So you would change that to 3 radical 4 times 2, because 4 times 2 is 8. The square root of 4 is 2. And you pull that outside where there's already a 3. So you multiply that and you would get 6 radical 2. So if you don't think of the first one, which is the same thing as what I got. So if you don't think of the biggest perfect square that goes into a number, then you just keep breaking down your number inside until you get it all the way simplified. So if this number has a perfect square that goes into it, if the number under the radical has a perfect square that goes into it, then it is not simplified and you need to keep breaking it down. Okay? Well, 52 is a fun number. I think about 52, I think about a deck of cards because a standard deck of cards has 52 cards in it. And that also tells me that there are 4 suits in a deck of cards, and each suit has 13 cards. So I know that 4 times 13 is 52. And 4 is a perfect square. So I can break that down to 4 times 13. And the square root of 4 is 2. So I'll pull that outside, 2 radical 13. And I know that is simplified. I need to put a box because the rest of them have boxes. Because 13 is a prime number. And if your number under the radical is a prime number, then you know it won't simplify anymore. Okay? All right. So I'm just going to do some examples. Round us out a little bit. Radical 60. The largest perfect square that goes into 60. And I believe that is 4 again. So this one is 4 times 15 is 60. And the square root of 4 is 2. So that is 2 radical 15. And that one simplify because 15 doesn't have any perfect squares that go into it besides 1. All right. 175. Seems like a big number. But since it ends in a 75, we know 25 goes into it. So 175 is 25 times 7. And the square root of 25 is 5, so bring that outside. 5 radical 7. 7 is prime, so that will not simplify anymore. 5 radical 7. All right, then we start getting to where there's numbers on the outside of the radical. And you have some of these on your worksheet as well. So I want to do a few of those with you guys. 3 radical 148. I meant for that to just be 3 radical 48. So let me fix that problem. I'm sorry, I miscopied from my notes on my paper to my screen. Let me say I didn't think about 148. So sorry about that, my friends. Y'all know I make mistakes, and I don't have you guys here to correct me, and that makes me a little sad. All right, so radical 48. So 4 goes into 48, 4 times 12, but I don't think that's the biggest number that goes into 48. Actually, the biggest perfect square that goes into 48 is 16. 48 is 16 times 3. So I keep my 3 outside, and I change the inside to radical 16 times 3. Okay, so I take my square root of 16, and that's 4. And I would pull that to the outside. But when I do, I already have a number outside. So if you already have a number outside, what you do is you take your square root, which is 4, and multiply it times that number that's already out there. So this is going to be square root of 16 is 4. 4 times 3 is 12. So this all simplified to 12, and then there's still a 3 under the radical. 12 radical 3. Okay, so you take your square root, pull it to the outside, and if there's already a number out there, you multiply it times that number. Square root of 16 is 4. 4 times 3 is 12. Okay, 12 times radical 200. Okay, so I'm just going to think about the radical for a second, and I believe the largest perfect square that goes into 200 is 100. So I change that to 12 times radical. 200 is 100 times 2. Okay, and I take my square root. Square root of 100 is 10. 10 times 12 is 120. So that's going to be 120 radical 2. That's my final answer there. All right, 7 radical 45. Well, I believe the largest perfect square that goes into 45 is 9. So I keep it 7 radical 45 is 9 times 5. And the square root of 9 is 3 times the 7 on the outside is 21. So 3 times 7 is 21. So 21 radical 5. All right. And that is simplified. Oops, I accidentally erased that. I think I have one more. Okay, yes, 448. Now, this one is actually one of your problems on your worksheet. So that's why I wanted to do this one. I don't know what number it is on the worksheet. I forgot, but I wrote this one down to do. But it is a problem on your worksheet. Okay, so 448. I don't really know a perfect square that goes into 448. That number's kind of big. Okay, but if you go back and look at your list, that can help you. Let me erase my blue lines. Okay, so any of these red numbers you can try. Don't waste your time using numbers like 24 because 24 is not a perfect square. You only need to test out these numbers. So I would try out like, since it ends in an 8, you might want to try out 144. 448 divided by 144 gets a decimal. So that's not going to work. Okay, so I think the first one I tried was 16. Yeah, let's do that. Let's try 16. Now, if you're smarter than me, you might already know the right perfect square that goes into that number, but I didn't. So I'm going to try 16, and I did. I had 448 divided by 16 is 28. Okay, whole number. I'm going to do it. Okay, 16 times 28 is 448. And the square root of 16 is 4, so I pull that outside. 4 radical 28. Okay, so I already know that my number is not simplified yet because 28 has a perfect square that goes into it. Because I know 4 goes into that, right? So I'm going to keep on dragging that out. 4 radical 28 is 4 times 7. Okay. What's the square root of 4? 2. 2 times 4 is 8. So that is 8 radical 7 is what I finally get simplified down to. And I know that's true because 7 is a prime number, so there's no perfect squares going into it. Now, since I could simplify it, then actually the highest number that really went into 448 was 64. And if I do in my calculator 448 divided by 64, I'm going to get 7. So let's just say, had I done it right the first time, it would have been 64 times 7. And the square root of 64 is 8, and that's 8 radical 7. So I still got there eventually. It just took me a little bit longer. So, like I said, if you accidentally don't pick up the highest perfect square that goes into a number, you can still keep on working and get there. But I just want you to try your best on this one. This one actually is a problem. I don't remember what number, so find the one that says radical 448, and there you go. You can do it the short way since I showed you how. But just give these a try, do your best. Like I said, this is not busy work. This is something that you will actually see again, I promise you. So, hope y'all have a great rest of your day. I miss you guys. Let me know if I can help you. I want to. This classroom sure is lonely without you guys, and I do mean that. So, have a good rest of the day. I'll see you later.